class. We'll talk about using abstract classes. So sometimes you'll want to create a superclass that only defines a generalized form that will be shared by all of its subclasses, but it should leave. It's actually leaving it to the subclasses to fill in the details. So you have a generalized form is going to be shared by all the subclasses, but each subclass is going to fill in the specific details of that class. So this class determines the nature of the methods that subclasses must implement, and in this particular type of a situation can occur when a superclass is not able to create a meaningful implementation for a method. So it's the case with the figure area method that we have actually worked on in the previous class. It is simply a placeholder and is not computing or displaying area of any object. So it's something that is really common when you start creating your own class libraries, and there are two ways through which this situation can be handled. The first one is you simply have that class to report a warning message, as I have shown in the previous program. Now, this first approach is actually not appropriate because you may have methods that need to be overridden by the subclasses for it to really have any meaning. For example, the class triangle in the previous example has no meaning if the area method is not defined. So we want a way to ensure that a subclass does override all necessary methods, and the abstract method is actually the solution to this problem. So what we do is we specify the abstract type modifier to actually require that certain methods be overridden by subclasses. So the methods are, we also call them subclass responsibility, because they don't have any implementation that is specified in superclass. Thus, a subclass must override them. So classes that contain one or more abstract methods must also be declared as abstracts. So to do this, we use the abstract keyword. We have that abstract keyword in front of the class keyword in the class declaration. Okay. Let's just come to an example. Let's create I'm gonna explain that concept more now with an example. Let's create a new class, and I want us to call this class abstract demo. Abstract demo. We call it abstract demo because we want to see how we can use abstract classes. A class that holds no meaning, but it leaves the objects to actually define their implementation. Okay, so for this particular example, I want to let me create I said for to create an abstract class, you start with the abstract keyword. You start with the abstract keyword before the class. So we say abstract, then followed by class, then followed by the class name. In this case, I'm using A. So I'm declaring A as an abstract class. Okay. So I have said that the methods that are declared in abstract classes, they can also be abstract. So I want to create an abstract method here. I'll just call it abstract void call me. Yeah, that is an abstract method. It is not doing anything. The method is there, it's not doing anything, but it is creating, or it is allowing, the class is allowing objects that are created from it to actually define their own implementation. So we can also have concrete methods in abstract classes. For example, here we have abstract void call me. That is an abstract method, but we can have a concrete method still there. So let's have void call me to void call me to. This is now a concrete method, and it's printing this message, system.out.println. Let's have it print the message. This is a concrete method. This is a concrete method. So it is inside an abstract class. So not all the methods that are in abstract classes are abstract methods. We can have concrete methods in abstract classes. Good. Now let's go to our main here. In our main, let's create our main method. So public static void main. Let's have string args square brackets then curly braces, and in the curly braces I want us to create a new object that is from B. So we just call it B is equal to new B is equal to new B. Okay. We need to, let's come here, we don't have B, so let's create B here. Yeah, let's create B that is going to inherit from A. Class B extends A. Class B extends A, and we give it void call me. Give it void call me, and let's have it print a message. Let's say something like system.out.println, and let it print something like B's implementation of call me. B's implementation of call me. B's implementation of call me. Yeah, so we have a subclass, so that now we can create this. So B is equal to B new B. Now we are comfortable to create that, so we can call the call me method now. B.call me, and we can also call B.call me too. Now remember that B.call me is call me is an abstract method, and then call me too is a concrete method. Let's run this. Now the output here, B's implementation of call me, and this is a concrete method. So let's look at this. Is a concrete method. This one is call me too, prints that. Then we have created B, a subclass that inherits from A, and it has the call me method that prints B's implementation. Now when we actually we create B from B, this is the method that is actually printed. You see, this one is not holding anything, it's not used anywhere. The call me method there, it's not defining the structure of any method. So you must have noticed that no objects of a class A are declared in the program. We have not declared any objects of a class A, and the reason is because it's not possible to actually instantiate we call it one instantiate an abstract class. You cannot declare objects of an abstract class. So the class A implements a concrete method called the callMe2, which is actually acceptable, and it also has an abstract method, that is the callMe method, and it can also include as much implementation as the programmer sees fit. So we can use abstract classes to create object references to point to a subclass. Yeah, we are using abstract classes. We are creating objects that can point to a subclass, but the subclasses do not actually hold anything. So let's improve our figure class. Now, since we have no any meaningful concept of area for the undefined two-dimensional figure in there, we can declare area as an abstract method inside figure. Now this will actually mean that all the classes that we are going to derive from figure must in a capital letter override the area method. Must override the area method. Let's create another class so that we can improve on. If you still have your code, you can simply open your code and work on it, improve it. As for me, I'm just gonna create a new class here that I will call abstract areas. Abstract area. Now the reason I love beginning afresh is because we might have people that are actually taking this lesson and they haven't taken other lessons previously. Okay, so we want to use abstract methods and classes. So we are going to declare the class figure that we declared previously as an abstract class. So to do that, we begin with the word abstract, then class, then the class name is figure. Abstract class, then the class name is figure, and this was taking double dim1, double dimension1, and double dim2. Okay, again we need to really create the constructor. So figure, and figure is now taking double A comma double B, and then we need to set up things up here by saying that dim1 is A and dim2, B is dim2. So after we have this constructor, we will need to create an abstract method here, area. Let's say area is now an abstract method. In other words, it is not holding, it cannot get the area of any figure. So any object that we create must have its area overriding this area. So we have abstract double area as a method, and we are not giving it anything, just that way. We have it just that way. Yeah, it's really important. Now we need to have let's have a subclass rectangle that is extended from the class figure. So we say class rectangle extends figure. Class rectangle extends figure, and we need to give it to create a constructor. So rectangle is gonna have a constructor that takes in two measurements, double A and double B, double A and double B, and then we need to call the the constructor of the superclass of rectangle that is going to take A and B that way. Okay, have an issue here. Let's see. The type rectangle must implement the inherited abstract method. Yeah, we are going to that, don't worry. Yeah, we're going to that. So we must, that warning already tells you that the moment we have declared this as an abstract method and now we are creating a class that inherits from there, then this class should actually implement an override. So we need to override area of rectangle. We need to override area of rectangle. So to do that, we will have the same name, the same return type, and the same method name plus the same input. Data signatures plus the same data signatures. We have double area, and then let's print something. System.out.println. Let's print the message inside area for rectangle. Inside area for rectangle. Okay, so let's correct this. Supposed to be out, not output. Then it must return, because we say double, so it must return. So we are returning the area of a rectangle is simply dimension 1 times dimension 2. So dim1 multiplied by dim2. That's what we are returning at this level. Great. So we can create another subclass, that is the triangle now. So we can say class triangle. This one extends figure as well. Extends figure. Is extending figure as well. And then we have to create its constructor. So triangle is also taking two parameters, double A comma double B, double A comma double B. Okay, again it needs to call the constructor of its superclass. So we say super A comma B. Also, so let's see, also we need to override the area. We need to override the area. So to override the area, we say double area. We have that, and then we have the curly braces, and inside here let's print inside area for triangle. So system.out.println, let's say inside area for triangle, and we need to return the area. So the area of a rectangle is obtained by dimension 1 being multiplied by the results of dimension 2, and it's divided by 2. Yeah, that is what it's returning. Okay, so now in our main, let's create the main method. So we can say public static void main. We say string args square brackets, and we have curly braces. So inside this we have to if we try to create a reference to figure, if we try to create, okay, if we try to create an object of the class figure, it will give us an error because the class figure is now an abstract class and we cannot use it to initialize any object. Let's try it. For example, to create a new object from the class figure, we need to say figure, let's say figure R maybe, and we say is equal to new figure. Now you can see the error, new figure, and let's give it 10,10. Now you can see the error. If we come to this error, you cannot instantiate the type figure. Why? Because the type figure is what? The type figure is abstract. So I'm commenting out this line of code, and I will add here and say illegal now. Illegal now. We cannot do that right now. Doing that is illegal because that class is abstract. So let's create. Now if we want to create any object, we can create objects using the subclasses. So rectangle R is equal to new rectangle, and we give it maybe 9,5. Give it 9,5. Then we can also create a triangle. So triangle T is equal to new triangle. We can give it maybe 10,8. We can also create a reference to figure. A reference to figure. I want you to see something. So if I say figure, fig ref, meaning fig reference, it is not giving me any error. So it is really okay, it is allowed, okay, to create a reference to an abstract class because there is no object created by doing that. We're just creating a reference. So figref is actually a reference to figure. Now we can say something like figref is equal to R. So that means now R is referencing to figure. Why? Because we have created a reference in there. Okay, so now we can print a message. Let's say system.out.println, system.out.println. Let's get the area of where R is actually concerned. So let's say area is, let's say area is plus that and plus figref.area, figref.area. Of course there we are referring to the method of area in figure. Then let's assign, we are referring the method of area to of rectangle. Now let's assign, let's reference figref now to T. Let's reference figref to T so that we can access the method or the area of the rectangle. And we say system.out.println, and what we are going to print here is area is let's have plus that plus, and what we are adding there is again figref.area, figref.area. Okay, now if we run our code, and let's see the output. Inside area for rectangle we are getting 45, inside area for triangle we are getting it's 40. Guys, it is no longer possible to declare objects of type figure. I have said this is because figure is now an abstract, and that is why I have commented out this line of code down here. So all subclasses of figure must override area. If you create a class that does not override the area, you actually get a compile error. So we are able to create a reference variable of type figure. For example, we have created figref as a reference variable, meaning that it can be used to refer to an object of any class that is actually derived from figure, but we cannot create classes direct from figure. So guys, I hope that is clear. I hope that is clear. Okay. So allow me stop there, guys. I'll meet you in the next class where I'll be talking about how we can use I'll be talking about the final. 3 uses of final. We looked at only the one use, but we are going to look at the 2 uses of final that are related to inheritance. So until then, you guys, you've got to stay safe.